Hi SQL folks, today we will talk about running totals. Now you who is watching this video probably already know about running totals. You might be working as a developer or DBA, and running totals is a very common requirement in data-driven applications, specifically business applications where you have to compute over numbers over a period of time. So how I want to approach this demonstration is first talk about what running total really is for the sake of completeness, and then discuss various solutions that we have. For example, using subquery, inner join, common table expressions, and the windowing functions. So we'll look at solutions that are really bad in terms of performance, and then we'll move up to better solutions. This is how I want to approach this. Now, the first thing that comes to our mind, traditionally what I've seen is developers resort a lot on writing queries that are like subqueries or inner joins. So the first two solutions for running totals here that I have in front of you is a subquery method and a inner join method. I'm going to start from right on the top here, where I will first explain you what running total is. But because these two queries are going to take a lot of time to execute, maybe a minute or two, I'm going to run them in a separate window, and while they are running, we'll understand the concepts, and hopefully will be done. The execution of these queries will be done by then, and then we'll look at the numbers and where things were good or bad. So let's take the subquery method first, and I'm going to put it in a new query window here. Let's just close this, and what I also want to do is we need this as well. So this is how you could do exactly when you are probably running these. So let's turn on statistics time in IO. Let's turn on the actual execution plan. This is the subquery method, and now let's go and execute this. Okay, let's punch in another new window, and in this one we are going to take the inner join method. Let's copy this, put it here, and let's take the statistics time and IO, because you need the actual runtime metrics to kind of compare the performance. Let's get this done. Turn on the actual execution plan, and let's run the inner join method. There you go. Okay, now in these two windows, we have the subquery execution going on and the inner join. Now let's get back to our main window. What really is a running total? Running total is like a cumulative aggregation where you're computing a number until a certain point in time, like over a period of time. So you have a starting point, and then you have a stopping point, and then you are computing the running total. In most cases, the running total is like up to date until this point in time. This is better understood when we look at an example. Let's say you have an order, and the order value for this order 1, is 10. The next order 2, the value is 15. So what is the running total until this point, until the point in question, which is 10 plus 15, 25. Now when you take order 3, the value is 20, which means you got to sum up all the orders from first until this point, until order 3. So 10 plus 15 plus 20 will give you 45. So the running total until this point is 45. In other words, it is the previous running total in the previous step plus the new order there, which is 20 plus 25, which also gives you 45. So on and so forth until all the orders are complete and the orders cease out. Or it could be like until the end of the month or until the end of the year. That is running total, a very, very common requirement in applications. Now, I have seen developers over a period of time, when you have to approach this, when you have to write a query like this, against tables that contain, let's say, order values, you will resort to either a subquery method or a inner join method. Now, you who probably will be well versed, you will be like, oh no, Amit, we are not going to write inner join or subquery. We will resort to the windowing functions. Yes, we'll come to that. But windowing functions were introduced in SQL Server 2012. What about prior or previous to SQL Server 2012? You still see a lot of these correlations in production use till date. Yes, both of these methods, the subquery and the inner join, use correlation, right? Which is like two versions of the same table. So if you look at the subquery method, you are creating two instances of this sales order header. So first, let's look at the data. We are talking about sales order header. Let me just order by the order ID. And we are going to play around with which attribute. Where is the attribute? Okay, that's total due column. So I'm going to do a running total of this on this attribute, total due, and look at the number of rows. We have 31,465 rows. All right, so we're going to compute a running total from the first order until the way end. I mean the 31,465th row. Okay, that's our numbers. So now we have two options, the correlation options, the so-called traditional mechanism. First is the subquery and the inner join. So let's just zoom out a bit, and if you observe, both of them kind of look similar in terms of correlation, and you probably have already guessed that subquery is more expensive than inner join. Subquery in this case would perform worse than inner join. Now this is quite evident from the window there right here, because this one was inner join, which is already done, and the subquery version is still executing. Now let's jump over to inner join now, which is already done. The execution is complete. It has taken about 2 minutes 28 seconds for the running total. Okay, so let's look at the number here, 2 minutes 28 seconds. Let's look at the output. And if you see the output, the first order 23153, running total 23153. Well, this is the first order, so the order value itself is the running total until this point. Then comes the next order. So this plus this, the first order plus the second order, is the total value there. Then the third order, so on and so forth. This is the running total going on. If you jump over to the execution plan, this is the plan that you get. It is a parallel plan and all that is fine. And this has taken a lot of time to execute. And you can see the cost here is primarily on reading the data. If you look at the cost here, 45% is on seeking itself. And let's take the cursor over and see the number of times you are reading the data, right? The actual number of rows that is being read. Why is that so? Because when you are talking about running total, you're dealing with thousands of rows here, like let's say for the sake of discussion, 30,000. So you're reading the first row, and then when you have to compute the running total along with the second row, you're reading the first and the second row again. Then when you come to the third row and you have to add up the value of the third row with the first and second, you're reading the three rows again. You're again reading first, second, and third row. Then again, when it comes to the fourth row, you're again reading first, second, third, fourth row, so on and so forth. So if you just do the mathematics with this, when you reach all the way up to the 30,000th row, you're constantly reading the data from top to bottom all over again to compute each running total until that point, which is like reading the same data again and again and again so many times that it just takes like more than 2 minutes for this job to be done. If you take this cursor over this clustered index seek, and I want to show you the actual mode of execution. Okay, estimated number of executions. How many times clustered index seek operation has executed? This is where. So the number that you can see here is 31,465 times, which means as many times as the number of rows. This is where things go so expensive. Okay, if you jump over to the messages tab, you will see CPU time, okay, elapsed time. So you know it's already more than 2 minutes. So 2 minutes 28 seconds. Look at the IO. So you have sales order header here and the number of logical reads, and then you have a work table. So just keep this number in mind. We'll come back to this in a moment. Okay. Now, if you jump over to the subquery method, the subquery method turns out to be more expensive. If you look at the execution time, first things first, which will catch your attention, is 4 minutes 38 seconds. So the subquery version is worse than the inner join method. Okay, let's jump over to the execution plan. The execution plan also looks more complicated than the inner join method. So totally different. Now, why is this turning out to be more expensive? With some observations around the extra operation here. So if you look at the clustered index scan, you will see the spooling coming into the picture, and all these iterators that are there in this branch of the execution plan, each of them have actually executed 31,465 times, as many as times as the number of rows. So if you take the cursor over spooling, look at the number of executions, right? 31,465. Okay. If you take the cursor over stream aggregate, look at the number of times stream aggregate iterator executed, 31,464. So either it is one row less or equal to the number of rows. Take the cursor over scan, this will again be 31,465 times, which means there's more work happening here. Where's the number of executions? Okay, this was one. Okay. So if I jump over to the messages tab here, I can see work table. There you go. So if you see, a lot of IO was happening here. A lot of IO was happening with TempDB here. So there's a work table created and you're reading the data back and forth. Again, this could be because of the spooling operation that is happening. Okay. So coming back to our original window here, these two methods, the traditional methods, are definitely not good in terms of performance, both the subquery and the inner join method. That brings us to the next solution, which is writing a recursive common table expression. There is a catch here. Even though this will execute pretty quickly, the common table expression method here, but this will only work when there are no gaps when you are computing the total. In an example like this, there will be no gaps because this is an orders table, and for each order there has to be a value, some value for the order, and then only the order exists, and you have primary keys on the order IDs, etc. But you got to be careful because if there are gaps, then this method will fail. Also, you need to be aware of, you need to put down the starting point that has to be hard coded here, and you have to use the recursive method. So you can put the max recursion because otherwise this will fail. You need to tell the execution engine where to stop, which will actually be the number of times this is going to recurse, which is the total number of rows. So maybe you may want to put them in some local variables and then execute. Maybe you could try out. That's why this is a bit tricky, but this works. So if you just go and execute this, we're going to turn on the actual execution plan. You will focus, the first thing you're going to focus on is the execution time, how much time it takes. Let's go and execute this. When you're executing this, this is done in about a second. So if you look at the status bar there, it just takes 1 second for this to execute. If you jump over to the execution plan, of course, you get a different execution plan, a plan related to CTE. But then things to be looked into here is from a development perspective, it's a bit tricky because you're hard coding some numbers there and you have to ensure that there are no gaps. But this works out well. So operator uses TempDB to spill data. Well, this could be done through, because there are not too many pages that we are spilling down. So if you just look at the sorting, and this may or may not happen in your environment. Maybe I'm running on a smaller system. That's why this is coming up, but not too much of a worry here because the number of pages are very, very minimal and the execution time is pretty good. If you jump over to the messages tab here, even from if you look at the IO numbers are pretty reasonable. Okay. Now, well, you have recursive CTE as a solution, but if you're not confident about the tricky things that it involves, then let's come to the solution, which is windowing functions. And when you talk about the windowing functions, the over clause, the very powerful over clause, it's a like a short circuit mechanism with the optimizer. When you're aggregating data over a number of rows, over clause allows you to compute any aggregation like sum, average, min, max with a single pass, right? You're computing any aggregation with a single pass over the data. In earlier solutions, you're going back and reading the same data again and again, but over will allow you to skip that. Now, when you are looking at the over clause, you have options like you can use the range clause, or you can use the rows clause, or you could just simply write something like this. Now, let's execute the first one, range clause. Okay, let's turn on the actual execution plan. Let's go and execute this. And how much time does it take? Wow, again, just 1 second. Jump over to the execution plan. You're going to get a very simple, straightforward execution plan. We are going to get into this plan in another video. I'll talk about that in a moment. Jump over to the messages tab and you look at the numbers. IO is all pretty good, like what you saw earlier. If you look at this one now, if you use the rows clause, things are going to be very similar in terms of execution time. Just 1 second, again, pretty fast. Look at the execution time there. Jump over to the execution plan. You're again going to see a simple execution plan, but range and rows has a difference. The execution plan is not same. We'll come to that in a moment. Or you could just simply write something like this, right? You're not bothered about range or rows. Just simply select what you want, sum total over, and you're ordering by sales order ID because that's the order you want there, and you're computing the running total. Let's go and execute this. And if you're doing this, this is similar to either rows or range. I'll talk about that in a moment. Let's look at the execution time, which is again just 1 second. Jump over to the execution plan. This plan is similar to either one of them, the range or the rows one. Now, the windowing function, the over clause, is the way to go when you are computing aggregates of any sort or running totals, like as an example of cumulative aggregation. Please use the over clause. The windowing functions are very powerful, and performance wise, they are superb. So this brings me to the end of the video where I wanted to talk about running totals and what are the different solutions. And obviously the lesson here is use windowing functions. Start using them. They're very powerful. Now the next thing is, what about the difference in these three executions? They tend to be similar in terms of execution time, slight differences in the execution plan, but you got to dive a little more deeper into which one is better. Is this one better or that one better? And I know you're thinking that, oh, well, the execution time was just 1 second in both of them. So what do you really need to look into? Well, the data that we are dealing with right now is small, but when you're dealing with millions of rows, then the performance difference between this one and this one is going to become quite visible. So I am explaining this in another video. This is our channel, the free video lobby on SQL Maestros, and you're looking at the free list on YouTube. So if you jump over to the member only list on YouTube channel, or if you're watching this on SQL Maestros and you jump over to the premium lobby where I do a lot of advanced tutorials, I am going to dissect the execution plans of these two, and I'm going to show you intricate differences between these two. I'm also going to look at runtime statistics, and I will tell you, we will come to a conclusion that out of these two, which one works better. So you're not just going to blindly take either one of them, you're going to take a more informed decision. So if you like this video, do put a comment. Of course, let us know how well have you understood and was this useful, and if you have any other solution. And if you want to go a step forward and want to explore the differences between these two in terms of actual runtime statistics and performance, then switch over to the members only list. Or if you're watching this on SQLmaestros.com, switch over to the premium lobby where you will see the advanced version of this. Okay. Also, friends, all this content we take from our masterclass. So if you are someone who wants to dive deeper into SQL Server troubleshooting, performance tuning, query optimization, then explore the masterclass recordings on SQLmaestros.com. There's another solution, which is the all-in-one bundle. So you have two different solutions. They're exclusive, the all-in-one bundle and the performance tuning masterclass recording, 40 hours. Either one, if you subscribe to, you get lifetime access, okay? Which means no annual renewal, nothing like that. You subscribe and you can watch the content anytime, anywhere, as many times as you want. So you kind of become a lifetime owner, streaming access. And this is HD recordings, deep dive content, comprehensive coverage, and everything is very demo focused and very practical. And friends, don't bother about scouting the internet for cheaper learning solutions, like going for basics, beginners, fundamentals, masters, advanced, subscribing to dozens of learning courses so that you get that comprehensive coverage. Take my word for it, just go for the performance tuning masterclass, 40 hours, and you're done with it. From start to finish, you have a very comprehensive coverage. And yes, if you're still in doubts, do watch the 2 sample videos that are there on the performance tuning masterclass video, the landing page. Watch the sample content, watch the testimonials, and there's another video that will show you that once you subscribe, how is our learning portal, right? What do you really get access to? How can you watch the videos? How can you download all the scripts, the demos, the slides, everything? That is also shown in a video. So yes, evaluate everything thoroughly and then subscribe to the masterclass and have lifetime access. If you have questions, write to our team at contact@sqlmaestros.com. I repeat, contact@sqlmaestros.com, and they will promptly help you with your subscription or if you have any clarifications to be made. All right, hope you enjoyed this video. Do put down a comment, and yes, try to watch the advanced version of this where I will explain you the differences between these two. Well, that's it for today. That's it for this video, and see you soon in another video. Happy SQL.